Welcome to Ask and Learn.
Hi there. We have a set of questions here centering around specific heat and heat capacity for water. So starting off with letter A. Letter A is asking about the specific heat of liquid water. This is a constant, so we need to look that up. And when we look it up, we see that it is 4.184 joules per gram degrees Celsius, or it could be joules per gram Kelvin, because a change in a Kelvin degree and the change in a Celsius degree is the same. The two scales just start at different places. All right, going on to letter B, the molar heat capacity of liquid water. Again, this is another constant. Looking this up gives us 75.40 joules per mole degree Celsius. Since this is the molar heat capacity, it's per mole degree Celsius. All right, so now the fun begins. Now we get to do a little calculating, because now we want to know the heat capacity of 185 grams of water. So we have 185 grams of water. We want to know its heat capacity. To find that, we are going to need to use our molar heat capacity from part B. And notice the key there is it's molar. So we need moles of water. So my first step here, I am going to use the molar mass of water, getting that from the periodic table, 2 hydrogens and 1 oxygen, adding them together. That is the mass in 1 mole of water. And then I can use my molar heat capacity of water. And that is 75.40 joules for every mole degrees Celsius. All right, so let's check out our units here. Mole is going to cancel. Grams, of course, cancel. So our answer is still going to have joules per degree Celsius. So 775 is the value I get. And that's joules of energy are needed to raise this water each degree Celsius. So to raise it 1 degree Celsius, this amount of water would need 775 joules. If you want to raise this amount of water 2 degrees Celsius, it'd be twice that value. All right, let me circle out my answers from A and B also, even though there was no work there since we just looked those up. Just want to go back and circle those. All right, let's move on to our last part of this question, letter D. Letter D wants to know how many kilojoules of heat we will need. To raise the temperature, we have 10 kilograms of water, and we want to raise it from 24.6 to 46.2. Well, to do this, we are going to have to use the equation that the amount of heat, or we could have Q here, is equal to the specific heat of the water times the mass of the water times the change in temperature. Remembering that delta T is calculated by taking the final temperature and subtracting the initial temperature. Okay, let's go ahead and plug in our values here. So the specific heat of water we found in part A, it is 4.184 joules per gram degree Celsius. The mass, we are given 10 kilograms. Since our specific heat is in grams, I want to convert this to grams. There are 1,000 grams in a kilogram, so I need to multiply by 1,000. And then finally, our change in temperature, our final temperature that we want to raise this to is 46.2 degrees Celsius. We started at 24.6 degrees Celsius. This gives us a difference of 21.6 degrees. All right, so finishing out our calculations here now. I get 903,744 joules. But when we read the problem wants an answer in kilojoules. I also should probably clean up my significant figures a little bit. So let's convert to kilojoules. There are 1,000 joules in every kilojoule. So I need to divide that number by 1,000. And then it looks like I need to round it back down to, let's see, 3 significant figures because my temperature had 3. So rounding this down to 3 significant figures, I get 904 kilojoules as my answer for the amount of energy it would take to raise that water to that specified temperature. All right. Thank you so much for watching.